Welcome back. The topic for today's video is classes. We will begin by looking at a program that is written without a class. Hopefully this will give you some intuition as to why classes are needed in C++ and how classes can help organize our code better. The program that we will be looking at is creating some kind of an employee management system. So for example, we want to store employees' name, employee's position, employee's salary, and employee's location in this employee management system. And we will use the tools that we've learned so far in this class. So for example, we will use vectors, functions, and references to create such a system. At the end of this program, it should be clear to you why it is disastrous to create an employee management system by this particular design choice, and how we can overcome some of these challenges by recreating it with classes. I will also show you the same program written with the class, so then it will be easier for us to compare which one is better. So first let's see how to store the employee information. Now to store employee information, I have chosen to use vectors. Vectors are resizable containers in C++ that can hold different data types. So it's a good choice for us to store our employee information. We will be adding new employees, we will be removing some employees, we can possibly sort employees by their pay rates. To do these things, it is good to store our employee information within a vector. Vector provides us with helper functions to easily add, remove, access randomly an element within a constant time. So first I'm creating a vector of strings that holds the employees' names. So the variable name is employee underscore names. It's initialized with an initialization list. We've seen this before. We can use braces followed by a list of elements to initialize vector. Similarly, I'm creating a vector of positions, which is again vector of strings, and then a vector of integers, which holds the employee's salary, and finally a vector of strings, which again holds the employee's locations. So this basically is the core of our employee management system. This holds all the attributes for a given employee. So suppose now I want to add another attribute in this particular design. I would need to create a new vector which holds the new attribute, and then initialize this particular attribute for each of the employees that are currently existing in our employee management system. Now let's see how to deal with this data. That is, how can we print all the employees in our employee management system. To do this, we can create some helper functions. So first I've created a function called print underscore employees, which will take the 4 vectors that stores the employees information and will use it to print it. Now let's think about what are the what should be the parameter type for this particular function. So since all the 4 vectors are used to read the employee's information and then display it on the screen, we can declare them as const references. So by declaring them as a reference, we will avoid the expensive allocation, copy, and deallocation cycle. And by making it a constant, we will ensure that these vectors are not accidentally modified within the function. Now let's look at the definition of the function. So again, all the 4 parameters are declared as const references. And within this function, I'm looping through each employee. So here I is an index, and I'm looping until I read all the employee information. So names.size will give us what is the current total number of employees that we have in our employee management system. And then we will access the ith element of each of these vectors using the square brackets operator. So we can print the employee information using this cout statement, and this for loop will print the employee information of all the employees that are currently in our employee management system. Okay, now next let's see how to add a new employee to our employee management system. To add a new employee, we will need the new employee's name, we will need the new employee's position, salary, and location. So I'm creating here 4 temporary variables. So here I'm creating a string literal, which is the name of the employee. Again, a string literal, which is the position of this new employee, his salary, and the place at which the employee will be working. So we have 4 arguments that we want to pass to this new function add underscore employee, which describes the new employee. And then we have 4 more parameters that we will be passing, which will add this new employee information into our current employee information system. So the additional 4 parameters are the 4 vectors that holds all the employees that are currently part of our employee management system. So now let's go to the definition of this function. Again, first let's think about which parameters should be a const reference, which parameters should be at least a reference. So here, since first 4 parameters are all read-only parameters, we will declare them as a const reference. That is, they will not be modified within this add employee function, and we don't want unnecessary copies, so we will create them as a reference. Now the remaining 4 attributes now needs to be a reference, right? So in this function, we will add the new employee into each of these vectors, so they cannot be a constant, and we don't want this additional copy allocation, copy deallocation cycle, so we will make them all references. Now within the body of the function, it's pretty simple. We just need to use this method push underscore back on each of these vectors to add the new name, new position, new pay rate, and new location to our global vector, which holds the information on all the employees. Okay, so now next let's look at how to search within this employee management system for a particular employee, and then access the employee's attributes and print it on screen. So for that, I'm creating another helper function. So find underscore employee will be the function that we will use to search for a given employee. We will search for the employee by employee's name. So the first parameter that will be passed to this function is the employee's name. And then we will pass 3 additional parameters to this function, which will be filled by the function. So here I'm creating 3 local variables, position, location, and pay rate, and I want the function find underscore employee to fill them. So once this function is called and returned, the position, pay rate, and location should be the position of the employee that we are searching for, the employee's pay rate, and the employee's location. So suppose we find the employee within our employee management system, we will have valid values for these 3 parameters. Suppose we don't find the employee within our employee management system, then this function should somehow let us know that it did not find the employee. So let's see how to use the return value to communicate to the main program whether the function could find the employee or not. Now the remaining parameters, I think you've guessed already, should be the 4 vectors that we've used to store the employee information. We will need to iterate through these vectors to search for a given employee. So we need to pass all 4 vectors to our program, to our function. Now let's go to the definition of this function. And first let's look at what the return type should be. So the return type should be a Boolean, right? So if I find the employee within my employee management system, I will return true, otherwise I will return false. So then based on the return value, I can either decide to use the position, name, and location or not in the main program. Now the body of the function is again pretty simple. We will loop through all the employees similar to before. I use the index here, and we will use names as the vector that will tell us how many employees are currently in our employee management system. Now within the for loop, we will check whether the name that we are searching for is part of this names vector. So we will access the ith name and then check whether it is equal to name. If it's equal to name, we know that we have found the employee that we were looking for. So we will query the other vectors that holds the employee's position, pay rate, and location at the ith position, and then fill the position, pay rate, and location variables that we have passed to this function. At the end, we will return true since we have found the employee that we were looking for, And suppose at the end of the loop we have not found the employee, we will just return false. Now let's go back to the main and check how we will use the return value. So here within an if condition, I'm calling this function and then checking whether the return value is true or false. So suppose the return value is false, since I have a not operator in front of it, this if condition will be satisfied and we should see a print statement that says that employee cannot be found. And suppose this function returns a true, then not of true is false, so we should go to else, and within else I am accessing position pay rate location that was filled within this function and printing this onto the terminal. Now the second one is just showing an example. The first one is calling this function by asking whether Rick is part of the employee management system or not. The second one is asking whether Jim-Bob is a part of the employee management system or not. So it's pretty much basically the same code, it's just a different employee. Now let's first run this program and see what will be the print statements, and then let's discuss why this is not the best way to design such a system. Okay, so first I want to print what is the current employee list. Notice we have initialized our employees with an initialization list, so we can just go ahead and print them. We don't need to add any new employees. So with our print underscore employee function, we can print each employee. We can use the same format. So first we have employee's name, then the position, pay rate, and location. The formatting also can be made to be the same for each employee by creating a function. Next, we were adding a new employee and then printing again the employee list by adding this new employee. Since we are using vectors and push underscore back method to add a new employee, the new employee will be always added to the end of the list, end of the vector. So here when I'm now printing the employee list after hiring Dave, you see that the last employee is Dave, his position is programmer, his location is Los Angeles. So again, that's great. So far everything is good. So now let's go ahead and check whether we can find employee Rick within our employee management system. Notice here Rick was the first employee, so we should be able to find Rick and then print Rick's info. So let's continue. Okay, so now we see that we found Rick and we can print Rick's information, which was the same as before. So Rick is a chief scientist, he makes $500,000 and then he works in space. Finally, let's check whether we can find Jim-Bob. And notice now we see the print statement which says that Jim-Bob is not found. So this is great. This program works and it appears to do everything that we were looking for. So we could successfully create an employee management system with this structure or with this design, wherein we can print, find, add new employees with this short program. Now let's discuss what are the downfalls of this program. The first downfall is, suppose I want to add 4 more new attributes to describe the employee. So for example, we want to add employee emergency information to this employee management system. We will need to create 4 more new vectors that holds those 4 new attributes. And we will need to extend each of the function that we have written by passing these 4 additional vectors to that function. So in terms of code, we will pretty much have to rewrite everything, or we will have to extend every function that was written. Now it is taking 4 vectors, we will have to add 4 more and then modify the body of the function to use the new 4 vectors. So this is the first problem. Now the second problem is that notice there are multiple vectors with the same element. So here I have 3 vectors, all of them stores a string. So it's pretty easy to change the order in which we are calling the function. So suppose I'm calling this function instead of names in the first position, I call it with position, names, pay rates, and location. This program should compile again. We will not have any compilation issues. The reason is both position and names are of the same type, so the function does not know what is the first parameter that it will receive. It only knows that the first parameter is of type vector of strings, second parameter is also of type vector of strings. So it's easy to make uh, errors like this in our program, but it will be pretty difficult to identify such issues. Suppose we have a program that's like 1,000 lines of code, it would be hard to identify such an error. Now, the next thing that can go wrong is, suppose I accidentally forget to initialize a particular vector. So the first three vectors are of length 5, the last vector is of length 4. Now the program again compiles successfully. So at compilation time, we will not know that there is an issue. However, at runtime, when we try to access the fifth element of this vector, we will get a runtime error. So again, so it will be difficult to identify such issues when we are writing a code, and only at a later point in your development cycle we will come across plenty of issues which will be hard to identify and resolve. So these are some of the problems. So the main thing was that if we want to add more and more attributes to describe our employee, we'll pretty much touch every single line of code that we've written so far, extended by adding these new attributes. And things like writing a function by passing parameter by value or by reference becomes even more important when we have a design like this. So for example, I have 30 attributes that describes an employee. I will need 30 vectors to store these 30 attributes. Now, if for any reason I create a new function which instead of taking these vectors by reference will take it by value, then now I will have 30 allocation, copy, and deallocation cycles. This can significantly hamper the performance of program. So it will become even more important as to what is the choice of the function that we will create, what are the parameter types, whether a parameter should be a constant or not. All these decisions will become more important with this design choice.